Okay, one of the nice applications of the Pascal triangle is that it helps us apply the binomial theorem very, very quickly. So this binomial theorem is interesting because it helps you FOIL binomials. So if you have an integer power, so like for example 5 in this case, or 3 or 4 or whatever, something like that, then you can actually expand the polynomial very, very quickly by following the binomial theorem. So let's begin with a plus b to the power of 5. So let's just kind of figure out how the setup goes. So there's a summation, so there's going to be a lot of terms to be added together, and k is going to go 0 all the way to 5 because that's the power of the polynomial. And next what we're going to be putting is the 5, choose k, so the k is going to start increasing, and then we're going to have a to the power of 5 minus k, so the power of a is going to be going down, while at the same time the power of b is going to be increasing. So let me explain. So first we're going to make k 0. So if we make k 0, we get 5 choose 0, and then a to the power of 5, b to the power of 0. Then 5 choose 1, and we increase the k by 1. So in the first step, the k was 0. In the next step, k is going to be 1. So when k is 1, the power of a becomes 5 minus 1, which is 4, and the b ends up with the power of 1. Okay, the next term is going to be 5 choose 2, because this time the k is going to be 2, and then 5 minus 2, 3, b to the power of 2, because this time the k is 2. And I keep doing that until I get to k equal 5. Okay, so there's the setup. So again, the numbers on the bottom will always match with your k. So that's a quick way to remember it. So they always match with the k. And the number on top of your choose is always the same. It's always 5 because that's the power of the polynomial. And on the inside, the powers of a and b are gonna pretty much alternate, right? They start with a high, and then a goes down, while at the same time b is going up, okay? So now we need to figure out what the 5 choose 0, 5 choose 1, 5 choose 2 are, and so on. Okay, so what I'm going to do is go to this page and look at the 5th row and copy the numbers there. So 1, 5, 10, 10, 5, 1. So the values are 1, 5, 10, 10, 5, and 1, and those will go in place of my 5 choose 0, 5 choose 1, and so on and so forth. So let's go ahead and put all the numbers in. And if I fill in the letters, I get 1a5 plus 5a4b plus 10a cubed b squared plus 10a squared b cubed plus 5ab4 plus 1b to the power of 5. And that's pretty much the end right here, okay? So as you can see, this makes foiling super easy. Imagine having to write down a plus b times itself 5 times in a row. That would be a terrible nightmare to go through. But with this binomial theorem, it makes it significantly easier. Okay, so pause the video here and see if you can try this to do the same on the next problem. Be careful with this one. Your a is going to be basically equivalent to x, whereas your b is going to be equivalent to -4 and then y. So think of that as being your b. So give it a shot, see if you can work it out, and I'll give you the answer in a minute here. Okay, did you end up with x4 minus 16x cubed y plus 96x squared y squared minus 256xy cubed plus 256y to the power of 4? Hope you did, and I tried to make it as clear as possible what my steps were. Again, keep in mind that I'm applying the formula that I gave you with a equal to x and b equal to -4y as that combo. Okay, so that's the end.